To perform 3NF decomposition, first we find all candidate keys of the relation. Then, we find a minimal basis. To do this, we need to determine which functional dependencies are unnecessary. If a functional dependency xb goes to A, where B and A are single attributes, and x goes to A exist in the set of functional dependencies, then the first functional dependency is unnecessary and would be deleted from the set of functional dependencies. After finding the minimal basis, we create one relation for every functional dependency in the minimal basis. Finally, we create relations for any candidate key not already included in the relations from the previous step. Let's illustrate this decomposition with some examples. Consider this relation with functional dependencies. First, we rewrite all of them in standard form. This is done by isolating all variables on the right-hand side. Now we need to find the minimal basis of this relation. We need to determine which functional dependencies are unnecessary. We can observe that the closure of A gives us AB and the closure of ABCD gives us ABCDE. We can already obtain B from the first functional dependency, so it is unnecessary in the second functional dependency. The functional dependency ACDF to E is redundant as ACD to E is sufficient to obtain E. The functional dependency ACDF to G is redundant as we can obtain G by using ACD to E and EF to G. Then the minimal basis is A to B, ACD to E, and EF to GH. The candidate key is ACDEF, so the new relations are as follows. Let's look at a more complicated example. First, we rewrite all functional dependencies in standard form. The first functional dependency is A to B. So all functional dependencies which are dependent on both A and B have B as a redundant value. Looking at BC to H, we already have C to H, so B is redundant. We notice that H is a candidate key. All letters can be reached using H. So all functional dependencies that are dependent on H along with other letters have redundancies. So all functional dependencies which are dependent on AEH can be reduced to H. This is a set of functional dependencies that we have so far. Can we spot any more redundancies? Consider DE to B. We can reach B without using this functional dependencies using DE to H, then H to B. So it is redundant. Similarly, DF to A is redundant as we can reach A by using DF to C, then C to A. Finally, BC to E is redundant as we can reach E by using C to H, then H to E. Now we have a minimal basis. The candidate keys are C, H, AD, DE, DF, so we have found all our relations. To perform BCNF decomposition, first we determine all FDs that violate the BCNF conditions. For every violating functional dependency x to A, we decompose the relation into R minus A and XA. We repeat this step until all relations satisfy BCNF. Let's look at an example. Here D to A violates BCNF, so we decompose the relation into ABCD minus A, which is BCD, and DA. But the original relation ABC to D is not preserved, so this BCNF decomposition is not dependency preserving. In this example, BC to D violates BCNF, so we decompose into ABCD minus D, which is ABC, and BCD. Both these relations satisfy BCNF, so the decomposition is complete. In the next example, we see that both functional dependencies violate BCNF. Starting with B to C, we decompose into BC and ABD. But ABD is not in BCNF. We need to decompose further. So looking at the other violating functional dependency, we apply the same procedure. So we decompose into DA and ABD minus A, which is BD. The final relations are BC, DA, and BD, which all satisfy BCNF, so the decomposition is complete.